Okay, so now we're going to look at hypothesis tests for a single mean. And again, we're going to use phantoms. You've done hypothesis testing for proportions. So we're going to look at these for means. So you have your phantoms, your parameter, hypothesis, your assumptions. You're going to name the test statistics. You have your observed p-value. You're going to make your decision and your summary. So first of all, again, your parameter is just like for your confidence interval, you need to identify what the population is in context. Okay, in this case, it's a mean, so you're going to identify what mu is. Now, for your hypothesis, remember that your null is always equal to, and then your alternative can be not equal to, less than, or greater than. Now, for your assumptions, you need to say that it's taken from a simple random sample. Again, of course, that's always the case unless you do an experiment, but we'll talk about those types of problems later on. Your population also needs to be normally distributed in some way. This actually should say sampling distribution is normal if the population is normal. Okay, it's also if the sampling size is greater than 30, the central limit applies. You could also graph it to show normality. Okay, and then the other condition, you also have the 10% condition, which we've talked about. Now, your test statistic is also going to be t. Okay, you're going to take the statistic minus the parameter divided by the standard error. Again, remember, a lot of times in this case, you do not know the population standard deviation, so you're going to use S. You calculate the test statistic, get your observed p-value, make your decision. Remember, the smaller your p-value, the stronger the case against the null. Okay, if you have to have something, if you need a sample alpha to go by, if it's less than 0.05, reject it. Okay, then you have your summary. Okay, so let's go ahead and do one of these problems out of this, obviously. Let's do one more. I'm going to graph this. Okay, it says the average high school GPA for incoming freshmen at a large university is 3.4. A sample of 6 freshmen who have declared English as their major was chosen, and the data is shown below. Is there enough evidence that English majors have a different high school GPA? Test this claim at a 10% level of significance using a p-value. Okay, obviously we're just going to test this claim. This says using a p-value. We always use the p-value. Okay, so let's start with our p. Okay, this is mu. Okay, so this is going to be the true mean. Okay, so GPA for incoming freshmen at a large university. Okay, so now we have the H. Now, we know that the claim is that it equals 3.4. Then it just says different. So this is our HO right here. So then for our HA, we're going to say that it's not equal to 3.4. So then let's move on to our assumptions. For our assumptions, we have a random sample of 6 freshmen. So we're going to say a random sample of 6 freshmen English major was taken. We have that. Then let's do that 10% condition before I graph it. So there's 6 freshman English majors, so we're going to say we can assume there are more than 60 freshman English majors at a large university. I mean, picture U of M, that's going to happen. Now, I picked this one because we haven't had to do a problem where you've had to graph it yet. So I'm going to quickly put these in the graphing calculator. There's not a lot of numbers. If you don't mind, I'm not going to show you me typing. So I've got 2.4, 2.8, 4, 3.5, 2.6, 3.0. Okay, so I just have these numbers in my calculator. I've got 1, 2, 3, 4, 5, 6, and they're right. So I'm just going to go to y equals. First, I'm going to clear out this data. Let's go to our stat plot. Okay, I'm going to turn on my first stat plot. I'm just going to make a box plot. I think that's probably the best way to do this. Make the ones with outliers. Okay, I'm going to hit zoom 9. Okay, so to me, I'm looking at that. It's approximately symmetric with no outliers. So I'm going to do a quick little sketch of this. So, not going to be perfect. I'm going to say the box plot is somewhat symmetric with no outliers. So I always like to say normality is plausible. I'm not sure why. Just don't say it is normal. You can say it's safe to, it's possible that it's normal. Just make sure you don't use that absolute. Okay? So then I need to go to my n. I'm going to say that t equals x bar minus mu. Just put my formula. For our test statistic, we don't know what some of these are, so I'm going to need to put them in. So t equals. Let's just go and run this test in my calculator. Now, one thing I'm going to tell you more about next week is what you're probably going to need to do and not. P-value by hand is probably not something you're going to be asked to do. So we're going to do a lot of this on the calculator because they're going to change the test a little bit this year. So I'm just going to go to t-test. I have data. They claimed it was 3.14. Just as a reminder though, this would have been a two-tailed test because it's equal to, not equal to. My data was an L1. Equal to, not equal to, I'm going to calculate. Now the reason I'm doing this first is you can see it just gives me my mean and it gives me my standard deviation, so I can go ahead and plug in these values. It also gives me my p-value right here. So looking at this, you can see that's a large p-value I'm not going to reject. It also gives me my test statistic. So I'm going to pull this away, but I'm going to plug in those numbers. So I'm going to have 3 minus 3.4. Remember, you get this value from the problem. Over, I'm going to ask you to trust me, they gave me a standard deviation of 6.54 over the square root of 6. From my calculator, it gave me the test statistic was negative, actually if I rounded that, negative 1.5. I'm going to move this up so you can see it. My observed p-value for my O is approximately 0.194. So my M is going to be fail to reject because that's greater than. Okay, so now I have my nice summary coming in. Straighten this. My summary. So at a 10% significance level, there's not enough information to reject the null. And support the claim that English majors GPAs differ. Okay, so let's see if I can make that come back into focus. Well, you heard what I said, and since the video was good up into there, I'm probably just going to cut it because you guys know the type problems I've had. So, all right.